I'm going to give a few examples of solving logarithmic equations by rewriting. The steps that I do with the logarithmic equations are the same ones that I do with exponential equations. I first need to isolate the logarithmic term, rewrite the logarithmic term as an exponential, solve it, and then check. For example, if I had log base 4 of x is equal to 12, there's nothing to isolate. Log base 4 of x has nothing else around it. There's nothing being added or subtracted from it, and there's nothing being multiplied or divided. So I can rewrite that immediately as an exponent. So base of 4 to the 12th power is equal to x. You can leave your answer as 4 to the 12th power, or you can calculate what it is. It's 16,777,216. It's the same thing, and it doesn't matter. Either answer is acceptable. Here's another example. If I had log base 2 of x minus 4 equal to negative 3, I look at log base 2 of x minus 4, and that term is isolated. There's nothing being added or subtracted outside of the logarithm. These parentheses show that the x minus 4 goes together as a pair. So right from there, I can rewrite that as an exponential equation. I'd have 2 to the negative 3rd power is equal to x minus 4. 2 to the negative 3rd power is equal to 1/8. So I'm going to rewrite this as x minus 4 equals 1/8. I need to add 4 to both sides. So when I add 4, I get 4 and 1/8. I can leave it like that. I can rewrite it as 33 over 8. Or I can write it as a decimal, 4.125. And then check to make sure your answers work. What happens is when you plug this back into the original equation, you cannot take the logarithm of a negative number. So when I plug that back in, I've checked it, it does work. Another example, 5 plus natural log of 2x is equal to 8. Natural log is just like any other log. It just has a base of e. So I need to get natural log of 2x by itself. I'm going to subtract 5 from both sides. So I get natural log of 2x is equal to 3. Now I have the logarithmic term isolated, so I can rewrite it as an exponential equation. The base of a natural logarithm is e, so I'm going to write e to the 3rd power is equal to 2x. E to the 3rd power is just a number, so I'm going to replace e to the 3rd power with 20.086. I want to solve for x, so I have to divide both sides by 2, and I get x is equal to 10.043. Check that, make sure that you take the natural logarithm of a positive number, and I've already checked that, it works. One more example. If I had log base 5 of x plus 4 minus log base 5 of 3x equal to 1. I have logarithm twice, so I can't rewrite it as an exponent yet. I have to condense these two. Since this is a subtraction problem, I'm going to divide the x plus 4 by 3x. So I'm going to rewrite it as log base 5 of x plus 4 over 3x. And that's equal to 1. Now I have my logarithmic term isolated. I can rewrite this as an exponential equation. So I have 5 to the 1st power is equal to x plus 4 over 3x. I'm just going to rewrite this so the variable's on the left side, 3x, and 5 to the 1 is just 5. 5 is the same thing as saying 5 divided by 1, and I'm going to cross multiply, so I'm just going to go ahead and write it as 5 over 1. When I cross multiply, 1 multiplied by x plus 4 is x plus 4. 3x multiplied by 5 is 15x. Now I have to solve for x. I'm going to subtract x for both sides. This will just give me 4 on this side and 14x. When I divide by 14, I get x is equal to 4 divided by 14. Reduce the fraction or write it as a decimal. And then make sure that you check your work. I've checked this already and I know that this works.